Hi there, I'm Energy Green Grandpa. Okay, I said I was going to talk about some of the projects that I've been involved in Kansas, where there are problems that we have to solve. And we try to do it in a scientific way. One of the first problems I dealt with was probably 1968. And they were having problems with feedlots in Kansas. We have cattle is big time. And a lot of times quite large herds are out grazing in Kansas. And then they bring them to feedlots to give them grain and fatten them up and then take them on the market. Now, what you go from a large space as hundreds of acres, if not thousands of acres of grassland, and reducing it down to totally hundreds of square feet of a bare feedlot. And of course, everybody knows what cattle do. They poop. And what are you going to do with it? Well, the science was at when they first did this, well, we can't get it all out of there. But let's build the feedlots on a hill. And so we can haul off a lot of that manure and use it on the fields and things like this. And then the rest of it can just kind of wash down the hill and maybe kind of be washed away in the stream. Well, not a good idea, because you have times when you have one whale of a rain and you have a lot of that manure that is washed into that stream. That manure is carrying on the decomposition process. That decomposition process requires oxygen. The oxygen is removed from the water, and you can guess what? Fish started bellying up, and this happened all over the state and many, many times. Finally got to a point where there's one of the largest feedlots in the state that had a problem where they had a rain, and it was a big rain, and it put what we call a slug of manure into the Neosho River. And that manure went down the Neosho River, and while it was doing that, it was removing all of that oxygen. The fish were bellying up, and it came into several miles down. By the time it floated through the city of Neosho Falls, just before it dumped into John Redmond Marismore, it smelled like bad. And so pretty well had to clear out the town for a couple, 3 days. But that kind of brought the end to it because it was so newsworthy, I guess. And so what are we going to do? Two things they found that could be improved with feedlots. Number one is put them on a slight slope, not a high angle slope, and then have a retention pond at the bottom. You could clean up your manure, but other extra manure would go into that retention pond. Later on, you could suck that water out and use it. And they use it today, a lot of it, and put it into digesters in which there's that decomposition, removes oxygen, but produces methane. That methane then can be used as a source of energy, which everybody's familiar with methane stoves. And that would be one source of that methane. Now, methane, the problem is that it is a very strong greenhouse gas. It's about 80 times stronger in retention of heat than carbon dioxide is. However, so you burn the methane gas on your stove and you turn it into carbon dioxide. But you have gone from one problem to another. Carbon dioxide could be a lesser problem. Methane itself, being in the atmosphere, is highly reactive to oxygen. So the half-life is about 10 years for methane. And after about 30 years, the methane is reduced, but it's producing carbon dioxide. Then carbon dioxide could be 200 to 500 years retention. Is not as strong as methane. So you've solved one problem, but you still maintain another problem by doing that. So that is one source that we have there of methane. So anyway, what they did was put the feedlots on a lower angle slope with a retention pond, and then also the problem that they had, a lot of the bunks that they put the grain in were wooden bunks. And so those were replaced by concrete bunks. Now, the government didn't come in and tell the ranchers what they need to do in Kansas. Pretty independent people. The government's not going to tell you too much of anything that you're going to go along with. But the ranchers and the government worked together and came up with solutions. And one of them was a slope, and the other one was the bunkers were made out of concrete. And so it made a cleaner operation for the health of the cattle, basically. So that was one of the problems that we dealt with. And you go over Kansas, or particularly in western Kansas now, you'll see a lot of these feedlots, and they'll be on low slope hills, and they'll have concrete bunkers. Another problem that we've had in Kansas is from the coal burning energy plants is that coal contains a lot of sulfur. And when you burn the coal, you're not only producing carbon dioxide, but you're also producing sulfur dioxide and other sulfates. That sulfur gets up into the atmosphere, it gets into the clouds and so on, and it reacts with the water and it produces sulfurous or sulfuric acid. And so we had for a long time a major problem, not only in Kansas, but all throughout anywhere that there were power plants, of acid rain. And so that solution had to be, that problem had to have a solution to it. And so the solution was made basically by engineers. It was a big problem, and again, people got hysterical about acid rain and so on. But like any other problem, it can be solved. And so the solution was that you would run the smoke from the stacks through a kind of a solution of water and limestone powder, and which was dissolved in the water. Limestone is made out of calcium carbonate, and what would happen would be a chemical reaction, and you would have the calcium reacting with the sulfur to make calcium sulfate or gypsum. And so then they could just remove the gypsum, and that took care of that particular problem. People thought we're not going to be able to solve it, but it was solved. Another problem, nuclear waste in Kansas, and this is a big problem everywhere. Let me tell you this, everybody just gets so frightened about nuclear plants and what I call the Hiroshima syndrome, that you don't want to have nuclear plants because they're going to blow up like an atomic bomb. Well, no, they won't do that. The big problem, though, is what are they going to do after the rods that contain the nuclear materials are tired, they're spent, they no longer can produce enough heat, and that's the idea of every plant, is to get enough heat to heat water, to turn it to steam, to turn the steam, turning turbines, and we talked about this before. The turbines then have magnets on them, and then the electricity that's produced is sent down the lines, and it ends up in your home. But the problem with the nuclear waste, though, they found that we could not find any place in Kansas for our nuclear waste. They've had troubles all over the country finding places, and they still haven't found a real satisfactory place to store nuclear waste. So you'd have a problem if you take the nuclear plant, you've got them in a big truck, and the big truck has a wreck, and there you've got nuclear materials, these rods, all these hot rods is what you would call them, all over every place. That was a big fear. So what was the answer? Store it on the site of the nuclear plant. And now they store them in our plant here in Kansas is Wolf Creek nuclear plant, which actually from my wife family farm, we can go to the North Pasture and see the nuclear plant. It's about 8 or 10 miles straight north of us. We haven't had any radiation problems at the farm because of that, but that then is just an aside. But they store those wastes on the plant site, and it's worked. That site's been there 40 years maybe. And it's the same has worked all over the world. But I was saying about the Hiroshima effect. Well, people say, what about 3 Mile Island? Well, yeah, it was kind of scary getting on top of it, but nobody was hurt at 3 Mile Island. Well, what about the big one there in Japan just pretty recently? You know, it was caused by a earthquake, and you had all this water coming in, a tsunami or whatever they call a thing coming in. It was huge, very expensive and very scary. Maybe one death out of that. Well, what about Chernobyl years ago and what's now Ukraine? What about that one? Well, 400 people were killed. Well, that's not good. But you have to analyze the whole problem. One thing, the plant was not built very well. Secondly, it was not managed very well. And so it got away with it. Just things started happening. And so you had all this radiation going everywhere, and a lot of people died. Those things, this has been over the last 50 years or so, and those are basically the problems that you have. Again, the big problem is what to do with the nuclear waste, and it seems to be that they're on top of that now. Always on a plant like that, when you have a large lake, because you have to have a source of water, and then you run it through steam, then return it back to the lake as it cools down. So that's another problem that we dealt with on committee, how we deal with this. And I had a special course in nuclear physics in which we dealt just specifically on nuclear plants. And then we always have problems with groundwater like everybody else. And I sat on many groundwater committees dealing with how we do this. One of the big problems has been, of course, where you had gasoline stations, and you have these big tanks. The gasoline station is closed down, or something else in place of it, and then these tanks rust out, and you start getting the gasoline into the groundwater, and you have to be able to deal with that. You have to spot them, and then you have to remove that, but it can be removed. That particular problem can be solved. And then another thing that I dealt with, there was a company, it's not Occidental Chemistry now, but I was on a committee that every month we dealt with the environmental problems and how to solve the problems for this company. And at that time it was called Frontier Chemical. And I always went to these. I wasn't paid, but the only reason I really went, I guess, was interesting meetings for one thing. But I tell you, they had chocolate chip cookies about that big, and plenty of coffee. So I didn't miss many of those meetings over a 12-year period of time. But we had several problems with that. So we had to be working with the groundwater. We had to deal with neighbors that thought the plant was going to explode and things like that. And we had to deal with this, and so we dealt with that. And that's another one that was a lot of fun, and I learned a whole lot about geology and about groundwater problems. And another one, this plant was, you've heard of the ozone hole, and you heard of CFCs, chlorofluorocarbons. And this plant was one of the major producers in the United States to provide the chlorine for the chlorofluorocarbons. And those carbons had a problem. They had two problems. Number one is they're really strong greenhouse gases. So they're adding to the greenhouse problems that we have now. But the bigger problem was that, and that was a scary problem, was that the gases got up into the ozone layer, which is above the stratosphere. And in the ozone layer, there's a lot of ozone, which protects us from particularly the ultraviolet rays, and that ozone layer was being destroyed. And the ultraviolet rays were coming in at a higher level. And so that was pretty scary. Well, how did they deal with that particular problem? Two ways were that, first of all, was denial. Well, that's not happening. It's not caused by CFCs. How in the world can CFCs possibly do this? You're up there with a bunch of molecules, and how are those molecules going to react with ozone? You have to have some type of a solid surface to have those on. And one of the guys that was working on this, I recall this, he looked at me, somebody straight in the eye, and said, guess what's up there in that higher level of the stratosphere? Well, I don't know. Ice crystals. The reactions occur on the ice crystals. Well, okay. Then they had to do, how did they solve that problem? They just took CFCs off the market. Now, they were used as refrigerants, and they have some replacements on that, or if they're using any CFCs, they make sure that they don't get away. So that was another one that was kind of fun to deal with. But that's, what my whole point is, this whole business of climate change can be solved, but you got to work together. You as citizens, the government, and right now, we need to talk to the government to do something about this. No, it has to start with you, and that's not shouting at the government. You need to understand the problem in the first place. But also, every one of those problems was solved by citizens working with the government and working with companies to solve the problems. And we can do that same thing with climate change. Now, I'll tell you where the money's coming from. You say, oh, well, we got to pay higher taxes so we can improve these things. You know, I don't know exactly what the industries that are that produce the greenhouse gases, those industries are worth probably trillions, and they're smart enough to see that this is a problem and we have to do something about it. And what can be a big role in doing that? Develop technology to replace your greenhouse gas producing fuels. So you just pour that money in other technologies, and that's what they're doing right now, is putting that in. Is it going to happen tomorrow that will have us all done? No. Is it going to happen 20 years? No. Is it going to happen ever? Not completely ever, but I would probably predict in 20 years, with a concerted effort of the people, the government, and industries working together, that the problem will be about 90% solved.